can you solve an inequality? An inequality uses greater than, less than, greater than or equal to, or less than or equal to compare two expressions. One solution to the inequality x is greater than 5 is x equals 7, because 7 is greater than 5. Inequalities have infinitely many solutions. Let's graph all of the solutions of x is greater than 5. What is true about the solutions of any inequality? What are some other solutions to x is greater than 5? The solutions are the values that make the inequality true. Some other solutions to x is greater than 5 are, for example, 6, 8, 6 and 5/10, and 7 and 1/4. Remember, the solutions include decimals and fractions, not just whole numbers. Step 1. To graph x is greater than 5, draw an open circle at 5 on a number line. The open circle shows that 5 is not a solution. Why is 5 not a solution? 5 is not a solution because 5 is greater than 5 is not a true statement. Step 2. Find some solutions and plot those on a number line. For example, 7 is a solution because 7 is greater than 5. Which of these is another solution?
Select your answer.
Nine is a solution because 9 is greater than 5. Plot the solutions 7 and 9. To find numbers that are greater than on a number line, in which direction do you move on the number line? Are the numbers that are plotted located to the right or to the left of 5? To find numbers that are greater than on a number line, you move to the right. The numbers that are plotted are located to the right of 5. Step 3. Start at the open circle and shade the solutions you found. Draw an arrow to show that the solutions go on forever. The last whole number shown on the number line is 10. Is 10 the greatest solution to the inequality x is greater than 5? Explain. No, the arrow pointing to the right shows that the solutions go on forever, but only part of the number line fits on the screen.
Graph all of the solutions of the inequality x is less than 8.
To graph x is less than 8, draw an open circle, the word open, sorry for the writing. I don't know what's going on. Open circle at 8 on the number line. 7 and 4 are two of many possible solutions of the inequality. Shade the solutions to the blank of the blank circle you drew at 8. So, open circle at 8, 7 and 4 are two of the many possible solutions. And so we have to shade in the solutions to the left of the open circle you drew at 8. And that's it.
The barbecue beef dinner entree is the most expensive menu item. Some of the costs of the entrees are shown. What are all the possible costs of the menu items?
Write and graph an inequality. The possible costs of the menu items M are less than or equal to $12.25. So M is less than or equal to symbol $12.25. There are too many possible costs to list, so it is far more efficient to show the cost on a graph. So you have the $12.25 closed circle because that includes $12.25, and then the arrow is drawn to the left because it has to be less than that. So every number less than $12.25 is a possible solution or a possible cost.
There are no menu items on the child's menu at the museum restaurant that cost more than $8.50. What are all the possible costs of the items on the children's menu?
It tells us that the kids' menu restaurant costs more than $8.50. There are none. So that means that the kids' menu cost can include $8.50, but it is definitely not more than $8.50. So then we would draw a circle that is closed. It's $8.50. So $8.50 would be halfway between $8 and $9. So that's a closed circle. And then because that cost of those kids' items are not more than that, then you draw your arrow to the left of that number because it has to be all possible numbers less than $8.50. And so all of those numbers are all the possible costs of a children's menu.
A long jumper who jumps at least 18 feet qualifies for the finals. Which athletes, if any, qualify for the finals?
Write an inequality to represent the situation. Y is greater than or equal to 18. So here are the long jump results. And so 22 1/3 is London's results, and that is greater than 18. So that is a possible solution. Morgan is 16. That is not greater than 18. So Morgan is not an option for the finals. 18.5 feet is for Oakley, and that is greater than 18. So she is possibly, she will be going to the finals. And 20.5 is Parker, which is greater than 18. And so the 3 finalists would be London, Oakley, and Parker because all of their results are greater than the 18.
Which athletes, if any, would qualify for the finals if the length of a jump that qualifies for the finals were at least 20.5 feet?
If the length was 20.5 feet, and the key term here is at least. At least includes 20.5 feet. So that would include Parker because she is at 20.5, and that would include London because 22 1/3 is greater than the 20.5. So those two would be the finalists if that were the qualifying jump results.